right, here is our first confidence interval we're going to do from start to finish. And what better than C3PO and hyperspace jumps? So C3PO collects all sorts of information. In a sample of 50 randomly selected hyperspace jumps, it took an average of 42 seconds to check the coordinates and make the jump into hyperspace. The population standard deviation for this very important task is known to be 5 seconds. Find a 95% confidence interval for the mean time it takes to make the jump to hyperspace. All right, so we're going to start with P, and I'm going to write something like 95% CI mean time jump hyperspace. So really, you can eliminate a lot of words from that sentence and just scroll something down quickly that gives you the context. You don't have to go back and reread everything when you're writing your conclusion. Our assumptions and conditions. So the first one is simple random sample. So I wrote SRS, and it says that we have a sample of 50 randomly selected hyperspace jumps. So I'll just put a check mark after that, indicating that I do have simple random sample. You could put a little star there that says stated. The problem doesn't say anything about whether it's normally distributed or not, but the sample size is n equals 50. So that's bigger than 30 and allows the central limit theorem to kick in. So I'm going to circle or underline the word large, and I'll put n equals 50 to indicate that I know that I need that big sample size and what it is. And then lastly, population standard deviation. So sigma is equal to 5, and that's listed in the problem. So I just copied that down. The n, at this point, you only know one type of confidence interval. So you're just going to write one mean z interval. That's the only one we've done. And so that makes this really easy so far. So you look at the next chapter, we'll swap that out with something else. But for now, you can just write one mean z interval every time. I'm going to take our sample mean, which is 42, and plus or minus, I'll replace that 95% with 1.96. And then that 5 and that 50 were listed in my assumptions. So I'll just grab those off the assumptions and plug those in. And I get from 40.6 to 43.4 if I calculate that out. And we will go take a look at that in the Excel spreadsheet as soon as we finish up panic on this. So the C, we are 95% confident that the true mean time it takes to make the hyperspace jump is between 40.6 and 43.4 seconds. Okay, so hopefully that gives you a good overview of that process. And give me a second, we'll switch over to Excel and I'll show you how that spreadsheet works to calculate those numbers for you. All right, so here is the spreadsheet. And if you look at the tabs along the bottom, you'll notice that they have the name of the statistical process and the chapter it came from. So this is going to be good for the entire unit of 5. And let's go ahead and put these numbers in. So we had a 95% confidence level. So I'll write that as 0.95. The average from our sample was 42. Our population standard deviation was 5, and the sample size was 50. So once I put those 4 numbers in, it automatically calculated Z star to be 1.96. And so if I'm looking at this from the margin of error standpoint, I would say this is 42 plus or minus 1.39. Okay, and then it also calculated that lower bound and upper bound. So you have 40.6 and the 43.4. So that matches those same results that were on the slide.